In this video, I will explain how an IOTA transaction looks like and what a transaction bundle is. The squares in the Tangle represents transactions, and each new transaction should reference transactions which have no other transactions referencing them. These non-referenced transactions are called tips. This is tip 0 and this is tip 1. Each transaction consists of a bundle of transactions. If we zoom in into this transaction, this is the transaction zoomed out. This rectangle represents one transaction with current index 0. This is another transaction with current index 1. Here is another transaction with current index 2. This rectangle represents the last transaction. Each transaction has a unique hash. Here's a unique hash. Here's another unique hash. Here is another unique hash. And here is another unique hash. These transactions are connected with each other by the trunk transaction. This trunk transaction field contains the value of this hash, indicated by this line. This trunk transaction field contains the hash of this transaction. This trunk transaction field contains the hash of this transaction. Tip 0 and tip 1 are the hashes of non-reference transactions, meaning these transactions, this one and this one. The first transaction with current index 0 is called the tail transaction. The last transaction is called the head transaction. The branch transaction field contains the hash of tip 0. The same applies for this transaction and this transaction. But the branch transaction field of the last transaction contains the hash of tip 1. And the trunk transaction field of the head transaction contains the hash of tip 0. This transaction represents this transaction with tip 0 and tip 1. Tip 0 and tip 1. Another transaction will use this transaction, for example, as tip 0. So this arrow points to this hash value. All these transactions represent the transactions inside the bundle. This is the IOTA Lite wallet. If you look in the transaction history, you will see these links, the show bundle link. If you click on the show bundle link, you will see the bundle details. The first line is the hash of the first transaction with current index 0. The other lines are transaction 0, transaction 1, and transaction 2 with the address and its value. Address and value, address and value. Here is an example of an IOTA transaction where 3 IOTAs are transferred from Alice's address to Bob's address. This transaction consists of a bundle of transactions with current index 0, as you can see over here. Here's another transaction with current index 1. And here's a last transaction with current index 2. All these transactions have the same bundle hash. Here is the bundle hash, UMG. Here is the same bundle hash, UMG. And here is the same bundle hash, UMG. All transactions in the same bundle should be treated as an atomic unit. It means that either all transactions of a bundle are confirmed or none of them are confirmed. Every transaction in the bundle requires its own proof of work. See the different nonces in the transactions. If we look in our example, in the transaction with current index 0, this is its nonce. The transaction with current index 1 has another nonce, as you can see over here. And the same applies to the last transaction with current index 2. It has another nonce. Full node stores every transaction that they and their neighbors are aware of, which means all transactions in the bundle. Light nodes don't store anything. They are stateless. Light nodes use API calls to the full node they are connected to get the information such as addresses and balances. After a snapshot, all metadata, such as tags and messages, are deleted. Only addresses with positive balances are restored by the full nodes. There can be 3 different types of transactions inside the bundle. Output transactions, transactions where IOTAs are sent to one or multiple addresses. The IOTA Lite wallet can only send to one address. These transactions are easily recognized because the transaction value is always greater than 0 and the address does not belong to the sender. If we look at our example, this value is greater than 0, then this transaction is an output transaction. This address is the receiver address and not the sender address. Input transactions. There are 2 types of input transactions. Input transactions where the value is negative. These are the transactions where the complete balance from that address is spent. And input transactions where the value is greater than 0. These are the transactions where the unspent or not used IOTAs are sent to a new change address in the sender's wallet. And last, meta transactions. Zero value transactions are meta transactions. The signature message fragment of these transactions could either hold a signature or a message fragment. In our example, this is the first transaction. This is our second transaction with current index 1. You will see the value is negative. This is a transaction where the complete balance from this address is spent. The signature to sign this transaction is too large to be stored in one transaction. It requires 2 transactions. This transaction, where part of the signature is stored, and a meta transaction, where the other part of the signature is stored. This is transaction example 1. Alice wants to send 3 IOTAs to Bob. Alice's wallet starts with address 0 and adds the balances of the consecutive addresses until 3 IOTAs are reached or exceeded. Any extra amount over the payment amount will be sent to a new address called the change address, which means you will not have to worry about address reuse in typical cases. This is Alice's wallet before the transaction. This is her initial situation. She wants to send 3 IOTAs to Bob. The wallet starts with address 0 and finds 3 IOTAs. This amount is enough to send to Bob. This is a situation after the transaction. The 3 IOTAs in address 0 is completely spent and sent to Bob's wallet. There are no unspent IOTAs left. This is example 1. This is a transaction with current index 0. 3 IOTAs are sent to Bob's address. 3 IOTAs are completely spent from Alice's address. This is the last transaction with the value 0. This is a meta transaction where the second part of the signature is stored. This is transaction example 2. This is Alice's wallet before the transaction. Alice wants to send 2 IOTAs to Bob. The wallet starts with address 0. It has 0 IOTAs. It continues with address 1. It finds 5 IOTAs. 5 IOTAs is sufficient to fulfill the transaction. This is a situation after the transaction. 2 IOTAs is sent to Bob. Bob's wallet has a balance of 5 IOTAs. The 5 IOTAs is completely spent. As you can see over here, it's 0. 2 IOTAs is sent to Bob, leaves 3 IOTAs. 3 IOTAs are unspent and sent to the next address in Alice's wallet, as you can see over here. This is example 2. This is the transaction with current index 0. 2 IOTAs are sent to Bob's address. 5 IOTAs are completely spent from Alice's address. This transaction has value 0. This transaction is used to store the second part of the signature. This is the last transaction. The 3 unspent IOTAs are sent to the next address in Alice's wallet. This is transaction example 3. This is the situation before the transaction. Alice wants to send 3 IOTAs to Bob. The wallet starts with address 0. It finds a balance of 0. It takes the next address and it also finds a balance of 0. It takes the next address and finds a balance of 1. But that's not enough because we need to send 3 IOTAs to Bob. So we go to the next address. We find 3 IOTAs. The 4 IOTAs will be sufficient to fulfill the transaction. 3 IOTAs are sent to Bob. Bob's wallet has a balance of 8 IOTAs. The balance of address 2 and 3 are completely spent. As you can see over here, 0 and 0. 4 IOTAs minus 3. The 1 IOTA is sent to a new address in Alice's wallet, as you can see over here. This is example 3. This is a transaction with current index 0. 3 IOTAs are sent to Bob's address. 1 IOTA is completely spent from Alice's address. This is the first part of her signature, followed by the next part of the signature. This is a meta transaction because the value is 0 over here. Another 3 IOTAs are completely spent from Alice's address. This is the first part of the signature, followed by the second part of the signature in this meta transaction. The 1 IOTA unspent is sent to this address in Alice's wallet. This is transaction example 4. This is before the transaction. Again, this is Alice's wallet. She wants to send 3 IOTAs to Bob. Alice's wallet starts with address 0, finds 0 IOTAs. Next address, again 0 IOTAs. Next address finds 0 IOTAs. Next address finds 0 IOTAs. It finds 1 IOTA in address 4. This amount is not sufficient to fulfill the transaction. Alice's wallet shows a warning message because her total balance is insufficient. This is transaction example 5. This is the situation before the transaction. Again, this is Alice's wallet. She wants to send 1 IOTA to Bob. Alice's wallet starts with address 0, finds 0 IOTAs. Next address, 0 IOTAs. Next address, 0 IOTAs. Next address, 0 IOTAs. Next address, it finds 1 IOTA. This amount will be sufficient to fulfill the transaction. 1 IOTA is sent to Bob's wallet. Bob's total balance is now 9. This value is completely spent and there is no unspent IOTAs. This is example 5. This is a transaction with current index 0. 1 IOTA is sent to Bob's address. 1 IOTA is completely spent from Alice's address. This is one part of her signature. The second part can be found here in this meta transaction. Here is an example of an IOTA transaction where 3 IOTAs are transferred from Alice's address to Bob's address. In this example, you see an array of 3 transaction objects. This is the first transaction object, the second transaction object, and the third transaction object. These transaction objects all have the same bundle hash, as I have explained this earlier. A transaction object is formatted using JSON, JavaScript object notation. In the following slides, each transaction object key will be explained. These are the keys, etc. The transaction object keys described in these slides are based on iota.lib.js version 0.4.6. The hash field uniquely identifies the transaction on the Tangle. The signature message fragment holds either a signature or a message, which may be fragmented over multiple transactions in a bundle. The address fields hold the address associated with this transaction. If the value field is greater than 0, the field contains the recipient address. If the value field is smaller or equal than 0, the field contains the sender's address. The value field holds the number of IOTAs being transferred in this transaction. If this value is negative, then the address is spending IOTAs. If it is positive, then the address is receiving IOTAs. If it is 0, then this transaction is being used to carry metadata instead of transferring IOTAs. The obsolete tag will be removed soon. The timestamp is the Unix timestamp when the transaction was issued. The current index is the transaction position in the bundle. If the current index is equal than 0, the transaction is called the tail transaction. If the current index equals the last index, the transaction is called the head transaction. The last index is the last transaction position in the bundle. The total number of transactions in the bundle is the same as the last index value plus 1. The bundle hash identifies which transactions belong to the same bundle. The trunk transaction field holds tip 0 hash or the next transaction hash. If this transaction is not the head transaction, the trunk transaction will hold the hash of the next transaction of the bundle. If this transaction is the head transaction, the trunk transaction will hold the tip 0 hash. The branch transaction field will hold tip 0 hash or tip 1 hash. If this transaction is not the head transaction, the branch transaction will hold tip 0 hash. If this transaction is the tail transaction, the branch transaction will hold tip 1 hash. The tag field is a user-defined tag to easily find a transaction. The attachment timestamp field holds the timestamp after proof of work. The attachment timestamp lower bound field is a slot for future use. The attachment timestamp upper bound field is a slot for future use. The nonce field will hold the proof of work solution. The persistent field indicates if the transaction is pending or confirmed. If true, the transaction is confirmed. If false, the transaction is pending. Please note, the keys used in a transaction object are not finalized and may change in the future. In IOTA tutorial 9, I have explained what security levels are. There are 3 security levels, 1, 2, and 3. By increasing the security level, you increase the key size, meaning you increase the private key size. When a value transaction is created, the complete balance from one or more addresses are spent. These transaction objects' signature message fragment fields contains the signature. Depending on the key size, this signature is fragmented and stored in 1, 2, or 3 transactions. This means, if you use security level 1, the signature is stored in 1 transaction. If you use security level 2, the signature is split up across 2 transactions. If you use security level 3, the signature is split up across 3 transactions. Here's an example. Alice has 3 different wallets. Wallet 1 using security level 1, containing only 1 IOTA at address 0. Wallet 2 using security level 2, containing 1 IOTA at address 0. And Wallet 3 using security level 3, containing 1 IOTA at address 0. Alice makes a transaction from Wallet 1. 1 IOTA is sent to address X. To see the transaction bundle, use this link. Alice makes another transaction from Wallet 2. 1 IOTA is sent to address X. To see the transaction bundle, use this link. And last, Alice makes another transaction, but now from Wallet 3. 1 IOTA is sent to address X. To see the transaction bundle, use this link. If you saw the transaction bundles, Wallet 1 using security level 1, the signature is stored in 1 transaction. Wallet 2 using security level 2, the signature is fragmented and stored in 2 transactions. And finally, Wallet 3 using security level 3, the signature is fragmented and stored in 3 transactions. By increasing the security level, you increase the signature size and thus the number of transactions needed to store the signature. IOTA signatures are larger than Bitcoin signatures due to IOTA's use of Winternit's one-time signatures to gain quantum resistance. Each single transaction inside the bundle consists of 2,673 tries, and much of it is taken by the signature message fragment, which has a size of 2,187 tries, which is approximately 82%. This is the algorithm to convert bits to trits. This is the algorithm to convert trits to bits. 2,673 tries equals 1.55 kilobytes, which means a single transaction inside the bundle requires 2,673 tries or approximately 1.55 kilobytes. A bundle can have one transaction, for example when you attach an address to the Tangle, but a bundle can also have an X number of transactions. For example, Alice has a wallet using security level 2 with address 0 to address 99, with each address having 1 IOTA. When Alice transfers her complete wallet balance to Bob, she creates a transaction bundle containing 201 transactions. 1 transaction to Bob, 100 transactions withdrawing 1 IOTA from each address, and 100 meta transactions to store the second signature fragment. Each transaction inside the bundle requires a proof of work. Let's assume a proof of work takes 20 seconds per transaction. Please note this 20 seconds is arbitrarily chosen. In this example, the total time to create the bundle takes 201 transactions times 20 seconds equals 67 minutes. You can easily create a transaction bundle containing lots of transactions. However, watch out for the proof of work. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.